Yes, sir.
Hello, everyone.
Hello.
Welcome
I
to.
want to be sure you can hear me first.
Yes, I can hear you very well. I
Can
can
you
hear you.
also see my screen?
Yes, I can see your screen.
Okay.
All right, okay. So, and I can see your face as well.
Okay, thank you.
All right. So we have 17 people now, so it's a good time. We can start. I'm so happy to
Okay.
have you all here. So much an encouragement. This is our 5th event, and it's been a wonderful Zoom meeting. I know that all of us are looking forward to a wonderful time today, here today with Dr. Aliu Aminu Ahmed. But before we do that, it's always our practice to always have someone in the house to facilitate the session. Today I have with us Tayo Ajala to facilitate this session. So I will just introduce Tayo and then I hand over completely to Tayo to handle the session. Tayo is a research and development consultant and is quite a resourceful person. I know him personally, having worked with him for like 3 years in Oracle services. He has a lot of experience in instrument development and programming. He has lots of expertise in data management, and that makes him a valuable professional in evaluation. He's very good in analysis. He knows how to interpret data very well. And over the years, he has acquired more skills in interpretation of data to inform evidence-based researches. He has worked in policy making. He has worked in community and global development sectors as well. He has a master's degree in public health with specialization in medical science statistics option. He has contributed significantly to several projects being managed by national and international agencies in Nigeria and in other African countries. It is my pleasure to present to you Tayo, who currently works with Oxford Policy Management Limited as a consultant and who has good hobby for chess and football. And he also sings, for those who do not know. So it's my pleasure to introduce
That's nice.
TY, we call him Tayo Ajala. Over to you. So the evening is yours. And he's also an administrator in a learning forum. So you will hear my voice again. I'm a learner from this point. Thank you very much, Tayo. Over to you.
Thank you very much, ma. Sorry, that was a very... Okay, we are here to do data science. And let me formally welcome everybody to today's lecture. I hope we are set. Data science. For me, this is like one area I'm interested in. And thank you for the privilege that at least to facilitate this. So I have my personal questions. But before then, we'll allow the section to go on. Good evening, sir.
Good evening.
And we're happy to have you in our midst. So what I'm doing basically is just to introduce us and lay down the ground rules. Like for the duration of the presentation, we're expected to just mute our mic. We're expected to just take notes. If you have any question, you can post on the group and I will do all I can to make sure I ask your question. Please, there should be no interruption. Just keep your mic, keep your questions till the end of the presentation. And afterwards, you can ask your questions. So please, as the lecture is going on, just you can keep posting your question. We'll try to compile the questions and group them into similar questions and ask them at once. So, sir, once again, I want to say a very big thank you for accepting to join us for today's lecture. And data science, everywhere is data science, data science. Like there are lots of definitions for data science. There's big data, there's data mining, there's data scraping, data wrangling. So, but what we are interested in for tonight's meeting is data science and monitoring and evaluation. Okay, prior to this class, I had to go and do some research that, okay, what is data science? I saw lots of definition.
So you
Data
are in
science.
better position to discuss it actually.
No, 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 sir. No,
You
sir.
did some
Like,
research, that's nice.
no, no, no. Like,
Yeah,
I just
yeah.
went to at least get definition. What is data science? So there are lots of link, data science, big data, data mining, data wrangling. Like, so we just want you to help us tie everything together and see how we can apply it to monitoring and evaluation. So, without wasting
Okay.
more time, I want us with okay, just put up the sign of the hand as we welcome Dr. Aliyu Aminu Ahmed to give us more insight into data science, monitoring and evaluation. So I'll be going on mute now, and I'll want every one of us to do the same. Please just type in your question, and once the presentation is over, we'll do everything to ask your questions. Thank you, and over to you, sir.
Thank you very much, TY. And I'm pleased that you're a musician, so it's another added advantage. So actually, I hope I will meet your expectation in this group because my understanding, the scope of the discussion is for me to present my thinking how data science is linked to M&E, not necessarily training people on data science because it's very broad. So I'm trying to make a case why data science is important for M&E. So maybe if, because I think I have only 15 minutes to make that case, and if there is anything that is requiring maybe teaching data science, explaining data science, all these things, we can do it in subsequent engagements. The reason is that knowledge is very broad and it's difficult for you to put everything together within perspective or context in just 15 minutes. So those that are eager to learn, sorry, next time, I'm just trying to make a case now for why we need data science for M&E. So my presentation scope is limited to only making a case for M&E and data science. Thank you very much. So first of all, I would like to, I hope you can see my screen. Can you see my screen?
Yes, we can.
Fine. So I would like to make it clear that just an ordinary development worker with project management MSc from Salford, UK, and then a student of data science in Texas, and I read statistics and then had some few certificates here and there on impact evaluation. Though I have done a lot of evaluation at different levels with different projects. Now, I'm basically a businessman, an entrepreneur who found a niche in monitoring evaluation. So I established Monitoring Evaluation Institute, and then I supported the emergence of Nigerian Association of Evaluators, and also convened people that are interested in data science monitoring evaluation. So I maintain several platforms that have a total of over 500 people that are interested in that area. So that is basically about me. So this presentation is going to be in two parts. So the first part will be to discuss some basic definitions and concepts, while the second part will be to try to link M&E and data science, and why I feel M&E should be linked to data science. And I think I will say I was among the pioneers in that process as well, because the last time I was in Africa Evaluation Association conference, I discussed with experts, and one of them, Michael Bambaja, actually was very impressed that we are thinking in that direction, because he is interested in complexity evaluation. So the linking of data science and M&E is just starting, but in Nigeria, we have already thought about it a couple of maybe 2-3 years ago. So now let's look at the concepts, and let's look at why I think M&E professionals should be interested in data science. Well, you know, data is facts and figures or statistics collected over a period of time or whatever for certain purpose, for certain reference, or for certain analysis. So when you process data, you get information. But when you have the information, you will have knowledge. So data on its own cannot be really useful for you until you process it. A bag of rice is 20 naira or 20,000 naira. It is a datum, single data, single value. But you can tell somebody that bag of rice has increased to 25,000 naira. This is information. But you can tell the person that bag of rice has increased to 25,000 naira. So this implies that during rainy season, August, we are going to have inflation in food products. That is knowledge, because based on what you learned before, we are able to make some inferences. So this is why data is the foundation. However, when you are looking at data, data itself contains some information and noise. So that means that the data that you process, you have to remove noise from it so that you will say, yes, this is data. So information is basically data plus the meaning that you get from it minus the noise that you get from the data. So the basic challenge is, how do you identify and distill this noise in such a way that the noise will not be, what do you call it, will not influence your decision either positively or negatively. So you have to find a way of dealing with that noise. And most of the time you see when you have an independent variable, you have dependent variables, you will see you have an error term. Then you try to use maybe maximum likelihood and say, you want to minimize the error and get 0 and then get your model fitted and so on. So all this in attempt is you are trying to say that you want to have a best fit, not overfit, not underfit, but you want to have the best fit that you'll be able to say, yes, you can make certain predictions and so on. So now, what is science? Science can be intellectual and practical activity encompassing a very systematic study of several structures or behaviors for both physical and natural world. But you definitely need to do certain observation and experimentation before you say, okay, this is scientific. So it's really very systematic. So now combine the two together, you will get data science. So for you to be able to extract hidden patterns in data, usually large sets of data, that you are dealing with data science. So basically, data science has been in existence for a long period of time. In fact, statistics is exactly what data science is all about. It's just statistics. But because with the advent of computer people need to make things easier. And with the advent of so much data coming inside, coming to us, every day we are generating data. Our telephones that we call data. We go to a shopping mall, they enter the things that we buy, data. They give us a card and to identify we are a frequent buyer, data. Flights, data. So everywhere you go, there's a lot of data. So that means you have big data, a lot of data everywhere. So now somebody has to use technology to be able to manage the data. And surprisingly, technology for managing data started with statistics. Originally, computer generally started with a, a government wanting to count population census. So they now introduce punch cards and so on. That's how computers started. So building on it, we have so many programs to do that, and still most of these programs are working. So basically, the ability to get the patterns and understand trends, cycles, and so many things about data, that was makes up data science. So, but usually that data comes in large volumes, and you need to structure them and prepare them for analysis. So those statistical tools, those techniques, and the way you manage the data using those statistical tools, either to describe the data, either to prescribe certain things, are all, what do you call it, part of the data science work you do. So I would say that data science is mainly statistics, but with a little bit of technology in it. Okay. Now, you mentioned. Can I stop? Hello.
Hi, please go ahead. I'm trying to identify who it is.
Okay, no problem. Okay, but I hope it's legible. I mean, my voice is clear. Okay.
Yes, your voice is very clear.
And the writing on the slides are okay. Okay, fine.
Very good.
Now, when you said you have done some researches, unfortunately, I didn't, because I just want to like introduce the conversation. But I hope during your research, you see that data science has significant statistical components. So you have statistical methods, data visualization, statistical modeling, statistical computing, and then research on data and so on. Then the application of the data in the real world. So bulk of what data science does is statistics. And immediately I dive into data science, which I'm just a student. I realized that most of the work is statistics, but building on theory of statistics and then expanding using better, more robust applications. So now, but in real sense of it, it is not only statistics that drive data science. There are engineers, there are software engineers, there are computer scientists that actually are comfortable dealing with big data. There is mathematics, the traditional researches we do. But most importantly, I want you to see the cycle, in the set here in this Venn diagram. You see the one below, subject matter expertise. So whatever you are doing in data science need to be related to the subject matter that you are working on. So in this case, the subject matter is what? Monitoring and evaluation. So that is where the link comes in. You have to have expertise in your subject matter, in your field of work, to be able to apply data science. You can apply software in your subject matter. You can design M&E systems, dashboards, and so on. You can have traditional research approaches. You can use it for your M&E work. And all these, when you put them together, your expert in subject matter, your software engineering, your research experience, all this gives you data science. So basically, whatever you do, you realize that you are really inclined to be analyzing and dealing with data. So now, let me reframe our perception, or rather, let me talk about M&E a little bit. M&E is used to assess performance of projects and programs, maybe policies. And the goal of M&E is to prove that you have done it, what you have committed to do based on maybe certain agreed things. And then you try to learn and improve. So you plan, you monitor, and then you evaluate continuously. Why? Because you want to have very good decision. You want to make informed decision. So that's why you do M&E. So now in M&E, most of the times, the scenarios that we are presented with are logical. So you have a logical thinking to whatever you do. That's why you have results, but the results are coming in chains. So when you come, you approach the problem, you do situation analysis, institution analysis, resource analysis, stakeholder analysis, collaboration plans, everything. Then you come and say, okay, I need resources. This is the money that will address this based on this scenario. And then this is the theory of change I have, and so on. Then you say, okay, I'll carry out these activities and I'll see this kind of immediate deliverables or outputs. And then I want to see these changes and anticipate that at the end of the day, after a long period of time, I will see impact, and you try to see how you can sustain it. So those activities you do in the area of program development, or in the area of program implementation, or in the area that relate to population, all can be grouped into three. So the first one is the development of the program, but in developing the program, you usually have to do a bit of an assessment or evaluation. So that evaluation is like ex ante, like a baseline evaluation to understand the situation. Then you come and implement the program, and you now monitor what you are implementing. Then you come again and evaluate and see what at the population level. And evaluation can be of different types with different purpose that you are going to require to answer certain questions. But the questions are actually set from the beginning, so that when you see changes at the end, you will be able to determine whether you can attribute or you can say contribution to it. So that is M&E. So how this subject area relates to data science. So in M&E, they have standards or criteria for whatever they do, mostly the evaluation. So you can do some evaluation for relevance, evaluation for effectiveness, evaluation for efficiency, evaluation for sustainability, and so on. So that's how the layout is. So I will have scratched this so that we can see how we can now link the two together, linking M&E and data science. So why do we need data science in M&E? We need data science in M&E because we want to have better evidence, informed decisions. And all these require a lot of skills to come up with. And one of these skills is the ability to manage data and make those inferences. So however, I want to tell you that things have moved on over a long period of time. and people in the M&E profession are still stuck to the past. For example, you go and you see projects being designed using log frames, logical framework matrix. This is something that was developed in 1960. And if you can relate, at that time, 1960, I don't know whether there is even 286 computer. I think 286, 386, all this came in maybe towards 80s. And even the first computer that was developed, you can understand when I say it was very late. So 1960 was when the log frame was designed, and still people use it in M&E practice and say logical framework matrix, logical. While in this generation, you have more to that than just that log frame. Then people say, resolve framework, resolve framework. All these are tools developed in the 90s. 1990s, many people were not even born. Many of us maybe were in secondary school. And look at how we have changed over time. There was no cell phone that has this Zoom or WhatsApp at that time. And still, with all this quality technology, people are still stuck to that result framework approach. And it was developed by USAID, built on the log frame. Then people talk about Development Assistance Committee criteria for evaluation: relevance, efficiency, effectiveness, impact, sustainability, and last few months, they added coherence. Do you know that those criteria were developed in 1991? And since that time, it was just a committee report or minutes of meeting of that committee. Then they now came up with that criteria and it was accepted by development committee. And since that time, we are talking about development assistance criteria. And some materials or some projects that governments are involved in, or systems that development partners are promoting, especially, let's say, result-based management system, is just a management approach to manage things. And it was developed in 1999. And thereafter, still from the same Development Assistance Committee, they realized, look, we need to be more rigorous. We need to bring in real rigor or real data analysis, real thinking into this M&E thing. So evaluation should no longer be go and evaluate and come back, go and talk to people and come back. No, let us have randomized controlled trials in evaluations so that we will know at the inception what it was and then what is without. So be able to determine that without using a control group. So that concept also started resonating among practitioners in 2004. We are talking about 2020 now. More than almost 2 decades, we are still stuck there. So now, I want to submit that we can add value to the evaluation profession by being more rigorous and introducing the concepts of data science. And I just, what do you call it, say, curriculum, and then I copied and pasted here for you. You can see most of the things that is done is not new. Predictive modeling is just linear regression, logistic regression. Data visualization is just descriptive statistics. You check the minimum, the maximum value, the model value, the quantiles, all those things, and then you plot graphs, all this. Machine learning is just have different decision trees. You train certain models and see how they can best fit and retrain again and test and retrain. It's nothing new. Business analytics or business intelligence is just inferential statistics, hypothesis analysis of variance, all those things. So they are not something new per se. They are there. We need to use them so that we can make better, more robust more informed decisions. So then that means there is need for a shake hand between technology and human ability so that we can have good numbers to crunch and then see what value addition we can use. And to the extent we'll be able to predict and say, this is it, and then be able to prescribe and say, this is how it can be with certain degrees of confidence that really what we are doing is right. So when you are called as an evaluator to see impact of maybe conditional or cash transfers to people all over the country, you will now quickly analyze the data, quickly present the data, quickly be able to make predictions, and then quickly be able to conclude and say, this is what I'm prescribing as the solution, because you are going to recommend something that will be useful for decision making. So that handshake between your M&E skills and what technology can offer, that is why we said, let's think about data science, monitoring, evaluation together. So let me show you an example of what I was saying. There was industrial revolution long since 1784, something like that, when we realized that there is need for even having these working hours, all those things people started pushing to improve. Then towards 80s, I think incidentally it is a socialist, Karl Marx actually, I think it's Karl Marx, he was in Manchester at that time. He brought this concept of having good organization of labor and so on. Then later on, automation, small calculators, computers started coming in. But now we have gone very, very far. That data is generated in the cyberspace and Internet of Things, all the computers are coming together, speaking to each other. So you don't need to label yourself. You can just access certain data and make certain decisions. For example, satellite images are there. You can use satellite images and know exactly where poor people are. Of course, when you see there is no light at night in a location using your satellite maps, you know that these people are poor, they cannot afford electricity. Or you can check how people recharge their phones. You see in a certain location, they are charging 200 naira. In another location, they're charging 1,000, 5,000, 10,000. And you know, that location that giving all these charges of phone, you know that really they are richer. Or you can see use of internet. People in the rural communities don't have access to quality internet, all those things. This is because there is a power of data. For example, when somebody wants to know the traffic, you use your Google map and you see where there is a red line, the traffic is congested. There was a story, someone told me that someone packed 80-something phones and put inside a wheelbarrow and started dragging it. Immediately Google map picked the signal and said there is a hold up there. So now they started routing people. So there is a lot of things we can do with data because data is collected every day and you need to make informed decision. M&E is to what? To prove and then to improve, to learn and improve. So what a better way to prove than using technology? What a better way to prove than using reliable data with all the data quality standards? So data science is there to bridge this gap. And it's already achieving it. You can see people are no longer using paper forms. They use maybe their ODK, Kobo Toolbox, whatever, to collect data, boom, and then they get result, analyze it immediately, and it goes. So these are all the power of technology that brings to how we use data. So data means what? A quality decision. Data means that you are not biased. Data means that you have reliable information to disseminate. So there is need for us to improve on how we produce data, how we share data, and how we use data for monitoring and evaluation. But most importantly is for policy and effective program implementation. So you cannot run away from data. So let me touch a little bit about how a typical data scientist or someone that's trying to integrate data science and M&E things. So you look at these analytics approaches. First of all, depending on the complexity, but you know that basic descriptive analytics are what we are doing regularly. So some people will say, okay, I want to present bar chart, pie chart, all those things. Oh, well, they'll go for advanced instead of using Excel. Excel is very powerful, actually. Instead of using Excel, they say, okay, they want to use Tableau, all this. There are many programs. So nobody can say that they are perfect in all the programs. So just pick the one that you're comfortable with, and then you use it, and then you improve on it. You don't have time to learn everything to describe data or do data analytics. You just pick the ones that are relevant to you, and then you use it. And if you are comfortable that you are okay, then you now add more. So there is no monopoly. So everybody, knowledge is a vast thing. We are all learning every day, and we continue to learn to our grave. There are many things you can learn. So there are many things you can use for descriptive analytics. Then diagnostic. When you describe things, you'll be able to say, okay, this is it. This is what I've seen. Then this is how the thing will look like in the future. And then now you prescribe solutions. So you have your data. You now describe it, what happens, and then you kind of think of what will happen, and then you advise which decisions to be taken based on what you are seeing. So I'm putting this up because M&E itself is answering those questions. What? The inputs. How? The activities. And then answer maybe so what or why. All those questions are what M&E also does, and the data helps you do that. So you'll be able to analyze, with data science, you'll be able to analyze and tell why things are happening, and show in a simplified way to be able to communicate to a stakeholder. In M&E, you do the same. You analyze your data and then have your knowledge management approaches, and then find a way of disseminating or visualizing those results. Then you can do a little bit of statistical modeling. When you hear modeling, it's not something like that is very complex. If y is equals to a plus b, what is y if a is 2 and b is 3? Y is 5. So this is modeling, nothing difficult. But as it gets more complex when those variables have to be defined, and then you show the relationship, and you will learn with time how to do that. Machine learning is not anything that is, what do you call it, too complex too. Because when you have a model and then this model doesn't do, then you keep changing the variables and say, okay, this one will better give me a result. And then you now test and see, okay, but there are certain things that can be used to show you whether these models are good. Although this discussion is not about teaching people how to do that, it's about just giving a case. Then we will now say, okay, this is it, and then advise on how to make a decision. So your descriptive statistics is the regular thing. Histogram, quantiles, mean, mode, media, sampling, all those things. Your predictive analytics is about maybe time series analysis that are used to logistics regression, all those regression, neural networks, and so on. So all those things are what we are used to. So we already have databases in M&E and so on. So now I try to simplify it and see how these two things are related. Data science tools, I don't know them more. I don't know them much. I'm just trying to present them today. But you see, when you say data visualization, we are talking about descriptive statistics. When you say data mining, we are trying to get all the relevant data. It's baseline that we are trying to do. So baseline descriptive statistics is all about what? Descriptive analytics. So it's all analytics. So predictive analytics that they are talking about is mostly looking at potential outcomes of the data so that you can advise, and statistical models that are relevant, and then something to test and see how it can be used to predict something. So somebody's salary is this month, and then based on the model, you know that after 10 years the salary will be so. So you look at the past records of salary history and then come up with that and say, okay, this is the burden in terms of salaries of staff for this organization, and then you do evaluation and advice. So why people mix it up? People think that evaluation is only for development projects. So, and the reason is very obvious. The origin of log frames are from military. So they are like very maybe strict on that. And then people, the second one, result framework, come from USAID. So people tend to think that all you do, you have to respond to development work. While in real sense of it, everything that M&E does, based on the lecture I had in this forum last week, you will see is actually social research or action learning and so on. It's just a piece of it. So it's not limited. Science is just something that you can apply anywhere. You don't have to limit yourself to development. But because development partners pay for that, and they're the ones interested in accountability because the money they use are taxpayers' money, then people are more inclined to getting jobs around that. So decision making in terms of prescriptive analytics, you see they try to find best strategies, recommendation for action. And mostly these are the things that we recommend in our evaluation. So see, this is how they are related. So we are basically doing the same thing, but we are using technology and data to improve on it. I am presenting this to you as an example of how I think an M&E system looks like, and then the place where data is really, really needed. So you can see the result chain up there. So at the monitoring level, you need to be collecting data, analyzing data, and that one will filter into your data management system. And basically, you need a lot of data science work. When you hear data science, it doesn't have to be something complex. I promote data science, but doesn't mean that I'm a guru in computer programming and so on. You can be a data scientist by simply working with data and using data for decision making. So a lot of data work is done at the monitoring level. Then you have management information systems that are set based on your result framework and platforms. You have your reporting systems, document management systems. All these are expected of an M&E person. So M&E professional is challenged to be able to know how to use these systems, data management systems, document management systems. So it's a lot of work. We have to be interested in data. Then you go again and do data quality assessment. validity, reliability, timeliness, all those things. You are crunching numbers, you are seeing data, you are checking how you analyze this data, how you collect the data, how you report the data, which analysis tools, analytical tools we are going to use. All this is what? Data science. Then evaluations. Evaluations can be, you can use some technology to do evaluation. For example, when you are evaluating a disaster, you can take geospatial maps before the disaster happened and after the disaster happened. And so many things are becoming more and more complex. Then you are no longer putting data on paper. You use cloud storage. So all these things are data science. So there is no way we as M&E professionals can run away from statistics, which is actually data science. So data science is just like level 2 of statistics, and it is necessary as level 2 for monitoring and evaluation, because monitoring and evaluation tools that were developed in the 1960s are no longer sufficient to answer the 20th century and this fourth industrial revolution. So we need to know data science. So thank you very much.
Wow, thank you very much, sir.
Thank you very much. Thank you very much.
Thank you. Please, I want us to just send in a clap just to say a very big thank you. This is
Thank you
very,
all.
very comprehensive. Thank you very much.
So, TY, when they ask question, now you go answer because you do your research.
No, my
Thank you so
research
much,
was
sir.
just for the definition. Thank you very much, sir.
Thank you. God bless you.
Oh, so please, we can start posting in our questions now. Like just send in your question, anything around today's
When you see the question, pick the simple ones. You know.
I promise to do that. Yes.
Thank you. Yeah.
Right, so it's a very broad one, and I don't even know where to start from. Recapping everything you've talked about, started with definition of data to information to noise. Like I would say, I'm not familiar with that word noise, but I know it refers to like the things you need to
Error
errors.
values,
Yeah,
like
the
the
error
error
values
terms.
that you
When
need
you
to
are
clean
trying to
out.
minimize, like a model, alpha plus beta x plus epsilon. So
Yeah.
those variables that you try to minimize are the noise. Yeah.
So every data comes with noise, and you need to clean out those data. So from there, you went on to define data science and went back to the M&E subject, monitoring, evaluation, and you were able to link everything, why data science is important, and probably things that we are currently doing in monitoring and evaluation, that they are integral part of data science, that probably to us we feel maybe data science is a whole new field that probably you will start learning from the scratch.
No.
But somehow we are into data science now. It's just to probably expand the sources of our data. Like instead of just restricting it to the primary data, go to field, you collect data, secondary data, Dex review. Like there are other sources that you can get data. And you made mention of getting information from the map. And there was another illustration you gave about probably trying to do something around poverty index and location, and going to get information about people that recharge to 200 naira. So the first thing that came to mind was, okay, if we were to do that in Nigeria, like assuming 50 million people recharge 20,000, maybe after checking 200 naira, after checking the database. So in my head, I feel I don't know of any statistical software that you can upload the amount of data into. But I know with data science, there's a way you can do that. And that's the place of the big data, like trying to work with very complex data and making sense out of it. Like you the visualization, like it has been proven that over time the attention span has been reducing. So the best way to get people's attention is just to represent it in visuals, whereby people just get to see it and you summarize millions of data into graph, bar chart, pie chart, histogram, scattered plots. So you've said a lot of things. I don't even know where to come in. Like I wrote out some questions, but I think you'll answer them.
Thank
So
you.
that means as M&E practitioners, there's need to step up the game and probably learn some new things. And okay, let me just point out some things. Modeling, the data visualization, the machine learning, and the business analytics. So from what you said, I wrote out some like job roles: the data analyst, data engineer, statisticians, and the mathematicians.
Yes,
So
yes. Yeah.
um, so I don't know, like my question, let me just still ask my question before going to the group to ask the question. Like, is it possible to develop competence to becoming a data scientist? Like from where we are currently, like,
Mm,
okay, you're able to relate it to a lot of things that we are doing as
mm,
M&E practitioners that is already data science, but
mm,
like the new area, the emerging area, getting to the point of going to source for information from probably from the online, from website, from blogs, from the map that you even mentioned, like trying to
mm.
get information before and after just to do your evaluation. Like, is it possible to get to this point of competence as data
As
M&E
M&E practitioner.
practitioners?
Yes,
Yes.
let me come in here. I think you have. This is the kind of questions that I really want us to ponder on. Competencies. 3 years ago, I was invited to Ghana, JIMPA, by World Bank Clear Project to discuss how to develop curriculum for M&E, for MSc, PhD level. My contribution at that time, and I insisted, and really it helped. You see, first, I'll talk about the competency for M&E itself, because people did not really understand who is supposed to be an M&E professional in the first place. So that is one thing that is affecting us in professionalizing M&E. So it's like an open-ended question, open to a lot of perceptions and answers and so on. So we develop competencies of M&E professional, and maybe I will share with you some of the competencies of M&E, because M&E, we have officer, we have expert, we have specialists, we have, different kind of competency requirement. So, but in a nutshell, part of the M&E competencies is ability to do statistics, ability to understand project management, ability to understand theories behind those models you are using. So if you are able to understand theories behind the models, quantitative research, qualitative research, all those things are part of the competencies for M&E. So then now when it comes to data science, we need to be able to sift out clearly what are the competency requirements to be called a data scientist, or to be called M&E practitioner with data science bias or something like that. Why I say so? Data science is very broad, very broad. So some people are purely computer engineers, artificial intelligence, robotics, and they call themselves data scientists, because what they use for industry they are in, like banks and so on, require them to apply those technology. So for example, somebody will be an expert in just imaging, how to do use image to understand patterns and so on. And he can spend all his life doing that. And he can say, I'm a data scientist because I use data image to generate models and predictions and so on. So it's very broad. So as M&E, the kind of knowledge we need from data science is the basic knowledge, basic understanding of how we can use the data, manage the data, so that we can use it for our own decision making and to support our evaluation practice. So, and that one we already know. But the only thing is that, as you asked earlier, are there programming languages that can help us do faster with a lot of big data? Yes, that is why we come in. So as M&E experts, you'll be given evaluation of a program that is for the whole country. And that program, they need you to give them answer in 6 weeks. Then the question is, if you don't know data science, how will you even select, randomize, and select your sample? That simple activity, if you are a data scientist, maybe you are using our program, sample, bracket, the population, comma, what you want, close it, boom, you do the sample. You understand me? So you have one code, and the code is giving you that sample. Then there's somebody want to say, so mean, mode, media, quantile, first, second, third quantile, all those things. Boom, you write summary, enter, boom, you see all the data that are thousands of data are summarized for you according to, you can, this is why we need to learn a little bit. I'm not saying that we should be experts in all this technology, but we use it piecemeal, what we can benefit from to make our life easy. So in terms of data, that whether these technologies can be available here, they are already here. There are people in this country that are coding things that will marvel you. There are people that are super in all these things. We have them, especially these young guys. You see, a lot of technology hubs are present in all these states. We went to so many technology hubs. One of the hubs here, my brother was like pushing, he's doing it. If you see what young people are doing, you will marvel at how you can do all these things. You mentioned something to do with extracting data from all those social media, all those things. Already is part of M&E. It's called media monitoring. You can, you can monitor media, see how some words are all mentioned, sit down, look at the comments, analyze them. All this is there for a long period of time. The only thing is that you upgrade it gradually based on the technology available. So how do you go at it, and what competencies you require? The fact that you are an M&E practitioner, you already have scaled one hurdle. So curiosity. You need to be curious to find the low-hanging fruits, learn and use and move on. And you can never learn data science through only online videos, all those videos they show what is data science, all this. You cannot learn data science like that. You cannot learn M&E like that too. The way you learn is that you participate in a data science project or participate in M&E work or profession. As you are doing it, you will be challenged to solve or answer those questions. And as you are answering, you will be marveled at the kind of knowledge you will gain. So keep challenging yourself, and then do not be afraid to say, I don't know. Do not be afraid to seek for knowledge, no matter where. We continue learning. So as M&E, the competency skills are already there. We have a little bit of mathematics, whether it's statistics. We have a little bit of project management. We understand how to conduct our evaluation, both quantitative and qualitative approaches. We all know these things. So you just keep expanding and building it slowly. So that is the way you build. If somebody comes and say, I'm a data scientist, but I'm into artificial intelligence, this and that, you're a very good data scientist. Me, I'm small one. You understand? So you learn small. If you are interested in specializing on those robotics, artificial intelligence, and so on, neural networks, although go and do it if it is useful to you. But some knowledge are not really immediately applicable. So you get the ones that are useful to you, find a project and use them, and then you will be happy that you are learning. So that's the only advice I will say. And then in terms of programming languages, unfortunately, Nigeria has never developed program language to my knowledge. I was searching to know whether we have indigenous program languages, but I couldn't. So those program languages are designed by people, sometimes for specific purpose. So all you need to do is you pick the ones that are there. But R programming, though is a little bit complex, but it's very useful when you are managing statistics, because statisticians that come together to put that program to suit them. So most of the things in R, because they designed in such a way to be helpful, you don't download everything in one place. So in R, you have your R, you install it, then you have R Studio, like an interface. Then anytime you want to use anything, you now go to the CRAN. And then there are many small packages that you download and use for that moment. So it's very light. So there are more than 10,000 of those packages.
Wow, thank you very much. Thank you very
Sorry, I
much.
took your time. I also wanted to go actually.
Oh,
Sorry about that. Sorry.
okay, it's fine. Sorry, but we have some questions. Let me just try and tie them together. Okay, the very first question, the person said they would like to know more on relating data science to, let's say, other database application like Oracle and MySQL. I think you already answered this question. So these are like different platforms, just the way we have the R, we
We
have
have
the
MySQL, we have
we have the
Visual Basic in
Python.
the past. All these are just tools.
Yeah, so
Yeah.
sorry to the person that answered this question. So just the way we have R, MySQL is just a tool that you can use
Forms,
to,
develop forms.
yeah, to extract complex data. And there's this very question I want you to answer before you leave. The person said they would like to know how data science in the future, if it will eliminate FGDs, KII for data collection, and probably just rather rely on technology like Google Maps, search engines, and phones to get our data from.
No, it will never eliminate it. In fact, I was researching some time ago to understand the limits that data science can go. You see, there is a discipline called phenomenology. So that phenomenology is a discipline that is related to those qualitative research. So the body of knowledge is always one, you understand? So they all reinforce each other. So eventually, what I see is that the need for qualitative data will grow, because professions like psychology, professions like so many professions rely on those aspects. So that human touch will never disappear. Technology is only going to make it fast to understand patterns and so on. But you need one-on-one to understand the complexity of human brain, emotions, there's one guy I was discussing with in terms of consciousness, and we were talking about his physics. So we are talking about what made a human being conscious. Then one professor saying, because the arrangement of molecules in our body that make us conscious. So we now said, okay, if all the molecules are deconstructed into one bucket, can it be conscious? Then he said, well, because the pattern is changed, then the consciousness will not be there. So those curiosity will continue to be in qualitative research, and it will never disappear. It will never replace anything. In fact, the need for it will be more, because when the data shows this, then you will begin to want to know what is the human feelings, consciousness, which machine does not produce. So as they grow deeper in science, they will try to see consciousness, try to make machines feel, try to make machines empathize, but this is long term, probably in the next 100 years. So for now, qualitative research, FGD, your traditional FGD, traditional key informal interview is even more relevant now than ever before, because they want to probe and know the why is somebody criminal? Why is what made that person to intend to do that? All this, the data cannot tell you. Yes, thank you.
Thank you very much for that.
Thank you.
Please, if you have any other question, you can post to the group. We'll try and get answers to your questions, but we need to close now. So
Thank
once
you.
again, I want to say a very big thank you, sir. Thank you very much. We really
God bless you.
appreciate. And he's taking a step further. For next week's training, we'll be diving more into data visualization and using Canva. So you get more information about that on the group. We really appreciate you, sir. But before you go, I want to invite Mrs. Toyin Akpan to come back. But before I hand over to her, I want to say a very big thank you for this opportunity. Okay, let me just say this. I started my M&E journey with her, like from NYSA to join her at Oracle Services, and I would say I had a very solid foundation, because moving on from there, going back for my MSc and to where I work currently, like, so just a smooth ride for me. So thank you very much, Mark, for the opportunity to facilitate this section and for everything so far. Over to you, Mark.
Thank you so very much, Dr. Liu. This is really wonderful. Thank you so very much. I can't thank you well enough for this wonderful thing that you've done for us. Not only have you whet our appetite, I think that you have also made sure that, you know, if we're confused about what exactly is data science, I don't think anybody is leaving this place without clarity. I think we're very clear. I am very clear, and I love the way you've also answered our questions. Thank you. God bless you very much. To one person that asked a question about, will data science replace all of these methodologies in qualitative that you mentioned? Definitely you've done justice to that, but what I want to ignite us to think about is more of how do we adapt technology to do those things that we physically do. A whole lot more have been happening. I have conducted FGDs virtually. I have done in-depth interviews virtually. I have used telephone a lot more. I've used WhatsApp to do quite some creative work. And so maybe what we're looking forward to in the young population, also for those who are expat population, is how can we stretch the boundary? How can you automate more? How can you make sure that things can be done faster? There's a limit to what physical person can do. If you want to be in two places, you can't be. But if you automate and you set up systems that can do this using machines, you can be in 10 places at the same time. Like at the very beginning, Dr. Aliu said, we're looking for more data to crunch. We need volume of data to crunch, to be able to see simulation, to be able to simulate and say, this is the pattern of behavior of people of this population or this segment of the population. Those are things that I think that coming out from what you heard from him stimulates us to think beyond the boundary of keeping to what we've always done. He also says something that I think for me is quite stimulating. He said most of the methodologies that we are learning now are also obsolete already at delivery. So you can imagine that we need to move further and further into real future. Let's innovate, let's create something. Let's begin to think beyond just adopting and taking the papers and adapting. Let's begin to think, what exactly are these that we need to do? How do we report objectively about the changes that we are experiencing? How can we adapt our own professions, what we know from different backgrounds? You remember he said so many things about every profession has a room in M&E, and every profession has science as well. How can we adapt all of these things? So he has brought us to more thinking, and I hope that in the next 1 week, that your thinking and ignition has begun. You know, so start to innovate, start to think creatively. And we have displayed a his contacts. So don't let our networking stop here. You remember our first session about networking and collaboration? When we ask questions, when you're thinking, don't let it end here. He's a good resource. Make sure you reach out to him. Make sure you bother him a little bit. Even if you don't do it physically, follow him. He has his footprints in social media. Try to look out for him. He has so much to offer. And I hope that this opportunity that we have, we're not going to let it just fly by us. So without wasting any more of your time, I want to thank Dr. Aliu so much. You have been a blessing to us today. We want to say thank you so very much. And we hope that next time we call on you, you will not say you don't know us again. Even at
No problem. Thank you.
No, we won't say that.
Thank you.
Dr. Ali,
Bye-bye.
thank you so much.
Thank you. Thank you so much.
all right,
Bye-bye.
everybody,
Okay, thank you.
so unmute and say thank you to him.
Thank you, sir.
Thank you.
Thank you.
Thank you,
Thank you
sir.
very much.
Thank you,
God bless
Thank
you.
you.
doctor.
Thank
Appreciate
you.
you.
Thank
Thank
you. We appreciate
you.
you. God bless
Yeah,
you.
good day.
Bye.
Thank you.
Thank
Thank you.
you.
Mubodi
Thank
Alaji.
you.
Mubodi
Thank you
Alaji.
so much, Mr. Lee.
Alaji.
Awesome.
Thank you so
So
much.
good night, everyone. Thank you. Good night.
Good
Blessing. Thank
night.
you.
Good night, madam. Thank you. Appreciate you.
Bless
Thank you,
you.
Auntie Lee. Thank you so
Thank
much.
you,
Thank
my
you,
sister.
Tony.
Thank you, Auntie Diola.
Good night, ma.
Good
Good
night.
night.
TY, thank you so very much. That was wonderful.
Thank you,
All
ma.
right. Thank you. God bless you. Auntie Bisi, good night.
Good night. Thank you, sis. Love you.
Love you too. Thank you. Imo, good night.